Hello students of grade 6. Today we are going to learn the chapter 13, that is fun with magnets. So let us start with the lesson. Paheli and Boju went to a place where a lot of waste materials was piled into huge heaps. So Paheli and Boju, they went to a place where there was a pile of huge heap of some waste materials. So something exciting was happening. A crane was moving towards the heap of junk. So when they went over that place, they saw that there was a huge waste material, a heap of huge waste material. So something exciting was happening there. What was that? That is what, like this crane. Can you see here? So this is a crane which was moving the huge heap of junk. The long hand of the crane lowered a block over a heap. So here you can see a long handle of this is what it is doing is it is lowering a block over this heap. So it is lowering this block over this heap. It then began to move. Guess what? Many pieces of iron junk were sticking to the block as it moved away. So what it was doing, it was taking this crane. This crane was taking a piece of block and it was moving this block towards this heap of junk. So what was happening, whatever iron pieces were there, it was coming and sticking towards this block. They had just read a very interesting book on magnets and knew immediately that there must be a magnet attached to the end of the crane that was picking up iron from the junkyard. So they immediately came to know that there is something, a magnetic substance inside this block. That is why these iron pieces are getting attracted, because they have read about a book related to the magnet. So as immediately when they saw this happening, they got a thought that it might be a magnet which is getting attracted towards this iron. You might have seen magnets and have been enjoyed playing with them. Have you seen stickers that remain attached to iron surface, like almirahs or the doors of refrigerator? So you might have known, you had enjoyed playing with the magnets. You have so many toys made up of magnet, and even there are stickers which are made up of magnets. So you will see some kind of toy cartoons made up of it, and behind those cartoons, what will be there on the stickers? There will be some magnets. So whenever you take that magnetic cartoons, those toys, those stickers, you will take near the almirah or near the refrigerator, what happens? They get attracted towards it because they have a magnet behind them. In some pin holders, the pins seems to be sticking to the holder. So this is a pin holder. As you can see, there will be pins. These pins will be attracted towards it because there will be a magnet inside this pin holder. In some pencil boxes, the lid fits tightly when we close it, even without a locking arrangement. So you have a pencil box, it's this kind. When you close it, what happens? They immediately get stuck to each other. In this case, we are not closing it tightly, but it is going and attracting towards each other, and it is getting locked up. Such stickers, pin holders, and pencil boxes have magnets fitted inside. If you have any one of these items, try to locate the magnets hidden in them. So what is happening when we are seeing this getting attracted towards? Now we can see this pin holder is getting attracted towards this holder, and this pencil box is getting closed by itself, and the refrigerator, when you will see this point, it will get attached to itself. They'll get attracted when it try to close them, and even these stickers. So when you see behind them, what will be there is nothing but the magnets hidden in them. So that is why the attraction is there. So let us see how magnets were discovered. It is said that there was a shepherd named Magnus, who lived in ancient Greece. Let us see how it was discovered. So there was a shepherd whose name was Magnus. He used to live in the ancient Greece. He used to take his herd of sheep and goats to the nearby mountains for grazing. So as he was a shepherd, he used to take the sheep and goat towards the mountain for grazing. He would take a stick with him to control his herd. The stick had a small piece of iron attached at one of the end. So what he used to do, you usually see that shepherds they will carry a stick along with them. So the same thing happened with this Magnus. He used to take a stick along with him, and he had a small piece of iron attached to one of its ends. So the stick used to have, one of the end of the stick used to have a iron piece attached to it. One day he was surprised to find that he had to pull hard to free his stick from a rock. So what happened, as he was moving around, he saw that one day what happened is it was very hard for him to free his stick from the rock. So from the rock of the mountain side. So it was very hard for him. As you can see, this is a shepherd. His name is Magnus, and he is a shepherd. He used to take his sheep and goat towards the mountains. And one day what happened, he used to carry a stick. There was an iron piece on the one of the end of the stick, and he was struggling very hard to remove this stick from this rock. It seemed as if the stick was being attracted by the rock. So you can see how he's trying hard to pull the stick, but it was getting attracted towards this rock. The rock was a natural magnet, and it attracted the iron tip of the shepherd's stick. So this natural magnet, what is the natural magnet here is the rock. The rock was a natural magnet, and it was attracted the iron which was there on the stick. So that is the reason why it was very hard for the shepherd to just dislocate that iron. It is said that this is how natural magnets were discovered. So by this we came to know that this happened, and after this incident we came to know that this is how the magnet was discovered. Such rocks were given the name magnetite, perhaps after the name of that shepherd. So after the name of the shepherd only the name magnet came. Magnetite contains iron. Some people believe that magnetite was first discovered at a place called Magnesia. So most of the people said because this name magnet came from the name of this shepherd Magnus, but a few of them says there is a place called Magnesia. From there this name magnet came, and before people used to call it as magnetite, and this magnetite contains iron. The substance having the property of attracting iron are known as the magnets. This is how the story goes. So now you understood how the people used to believe that how magnet was discovered is because of the shepherd Magnus, and few of them used to say it came from the place called Magnesia. From there only it got discovered. So there are two stories behind this, the story of the magnet. In any case, people now have discovered that certain rocks have a property of attracting pieces of iron. So in any case, we see that people discovered that certain rocks. So here you can see one of the rock which it was getting attracted towards the iron. Like that, in few cases, few property of attraction of pieces of iron was even discovered. They also found that small pieces of these rocks have some special properties. So these kind of rocks, small pieces of these rocks, they even have some special properties. They named these natural occurring materials as magnets. Later on, the process of making magnet from pieces of iron was discovered. So they named the natural occurring material as magnet. So whatever this naturally was getting attracted towards the iron, that they gave the name as the magnet, and later on they make a process of magnet from which they made pieces of iron. This was discovered. They are known as artificial magnets. So these are nothing but the artificial magnets. Nowadays, artificial magnets are prepared in different shapes. So now you can see nowadays what is happening. It is not a kind of rock what we see nowadays. They are of different shapes. So for example, they are bar magnets, horseshoe magnet, cylindrical, or a ball-ended magnet. So this is a horseshoe magnet. As you can see, this is like a horseshoe. So that is why they are given the name as the horseshoe. This is a ball-ended magnet. This is a ball-ended magnet because it carries two balls. So it's ball-ended. And this is a cylindrical one. And this is a bar magnet. So these are few of the examples of the magnet. So let us look into the activity 1. Take a plastic or a paper cup. Fix it on a stand with the help of a clamp as shown in the figure 13.5. Place a magnet inside the cup and cover it with a paper so that the magnet is not visible. So here we are asked to take a paper cup or a plastic cup, then fix it on a stand. As you can see how they have fixed it on a stand. Then what we have to do, we have to place a magnet inside this cup. So we are placing a magnet inside this cup, and so that the magnet is not visible. If you keep this in a paper cup or a plastic cup, what happens here? You cannot see the magnet inside, but we know that there is magnet inside, so it is not visible to us. Attach a thread to a clip made of iron. So what we have to do, we have to attach a thread to the clip made up of iron. Fix the other end of the thread at the base of the stand. So here you can see how they have done. It is fixed, one of the end is fixed to the base and the other end is attracted towards the clip made up of iron. So this is a clip. Here you can see one of the thread is having, one end is having a clip of made up of iron. The other end of the thread is attached to the base of the stand. Mind you, the trick involved here is to keep the length of the thread sufficiently short. So here the thread should be very short and it should be under this glass. Bring the clip near the base of the cup. The clip is raised in air without support, like a kite. Now here you can see how it is stood, how this thread and this iron piece has stood straight. It is not even taking anybody's support, or neither anybody is holding it, but it is standing automatically by itself like a kite in the sky. So how is this happening? Just because of the attraction between the magnet and this iron piece is taking place in between these two. That is why it is getting attracted towards the magnet. So this activity is telling us this. So let us look into the activity 2, that is magnetic and non-magnetic materials. So there is activity 2. Let us walk in the footsteps of magnets. Only this time we will change the position of the magnet and the iron. So what we are doing here, he is telling what Magnus has done. He has taken a long stick and there was the other end of the stick was the iron on it, and the complete stick was made up of wood. So here what we are doing, we are also doing the same trick, but here what we are doing, we are just changing the position, like magnet and the iron. The position of the magnet and the iron we are changing. There will be magnet at the end of our shepherd stick. So now what we are doing, the manganese, what he did, he was holding the iron along with him on the stick, but this time we are holding the magnet on the other end of the stick, not the iron. We can attach a small magnet to a hockey stick. So now what we are taking a hockey stick and attaching a magnet to the one end of the hockey stick. Walking stick or a cricket wicket with a tape or some glue. So here we are taking a hockey stick or a walking stick, which old men use, and or a cricket wicket with a tape on it and some glue. So let us now go out on the manganese walk. So this is what is called as the manganese walk, whatever we are doing. So through the school playground, what does our manganese stick pick up from the school playground? So what is happening here? Let us see. What about the objects in the classroom? Now when you attach this and move around in the playground or in the classroom, what happens? He's asking. When the magnet is there on the stick, what happens? It attracts the whatever is made up of iron, isn't it? So collect various objects of day-to-day use from your surroundings. So if you take that magnet and take it in your pencil box, what happens? The sharpener will have a small iron piece in it. So the sharpener gets attracted, and if there is a coin, that gets attracted. If there are some pins, they also get attracted. So some kind of etc., these kind of things which are made up of iron, they will get attracted for sure to the magnet which you have. So what he is telling us to do is collect all those things from your surroundings and test these with the magnet stick. So you take them and stick it to the magnet stick. You can also take a magnet, touch these objects with it and observe which objects stick to the magnet. So if you take an eraser, it doesn't stick, as we know it is not having any property of iron, so it does not attract to the magnet, whereas a sharpener, for surely it will attract the magnet. So prepare a table in your notebook as shown in the table 13.1 and record your observations. So here there is a table. He's asking us to take few examples and write down in this table, that is 13.1, and record your observations. So look at the last column of the figure 13.1 and note the objects that are attracted by the magnet. Now make a list of materials from which these objects are made. So what we are going to do is, he's asking us to take this table, that is 13.1, and here what we are writing in the first column, we are writing name of the object and materials which the object is made up of, that is cloth, plastic and aluminium, wood, glass, iron or any other substance. And what the last column is, attracted by magnetic or magnet, yes or no. So this is what we are going to fill here. So iron ball, it is made up of iron, so surely it will attract the magnet. So the answer is yes. And what about the scale? It is made up of plastic, so plastic does not attract the magnet, so it is no. So shoe, when you take your shoe, it is made up of leather, so do you think leather will attract the magnet? So the answer is no. So let us take one more thing, that is pencil. Let us take this pencil. So this is made up of wood, so does the wood attract the magnet? So the answer is no. So these kind of things he's asking us to make this table and note it down. So is there any material common all the objects that were attracted by the magnet? So these objects are not the same, all are different, which are attracted and which are not attracted to the magnet. We understand that magnet attracts certain materials whereas some do not. So some do not get attracted towards magnets, as we have seen just now, as we have observed, and even we have thought about the eraser, pencil and the sharpener. As we know that these things, few of them, they does not attract to the magnet, whereas few of them like sharpener, that and the zipper which you have on your bag, that also attracts towards the magnet. So these are few of the examples which you will find in your school, isn't it? Whereas your shoe which you wear and your clothes which you're wearing, they does not attract towards the magnet. The materials which are attracted towards a magnet are called magnetic. So whatever the substances which are attracting towards the magnet are called as magnetic. For example, iron, nickel or cobalt. So these are the three examples for the magnetic, which we call them as magnetic. They are nothing but the iron, nickel and cobalt. The materials which are not attracted towards the magnet are non-magnetic. So the ones which does not attract towards the magnet are called as non-magnetic, whereas the one which attract are known as magnetic. So magnetic and non-magnetic things or materials. What materials do you find to be non-magnetic from table 13.1? Is soil a magnetic or non-magnetic material? So do you think soil is a magnetic or a non-magnetic material? Is the question asked over here. So think about it. So let us look into the next activity, that is activity 3. So here we are asked to rub a magnet in a sand or soil. So the question which was asked to you, whether the soil attracts, it is a magnetic substance or a non-magnetic material. Let us look into this activity 3 so you will get a clear picture. So what he is asking us to do here is rub a magnet in the sand or a soil and pull out the magnet. Are these some particles of sand or soil sticking in the magnet? Is the question asked to you. So here what we are doing, we are taking a magnet and we are rubbing it in the sand or soil. Then what we are doing, pulling out the magnet from that sand, and you will see some particles of sand or soil, they will get stuck up to the magnet. So now what we are going to do is, now gently shake the magnet to remove the particles of sand or soil. So here you can see in the figure A that how the sand particles, they got attracted towards the magnet. So now what we are doing, gently shaking the magnet to remove these particles. So we are gently shaking so that the particles will come out. These might be so these might be small pieces of iron filling picked up from the soil. So here which you are seeing, they are not sand particles, but they are the pieces of small pieces of iron. So these are iron fillings which got picked up from the soil by the magnet. So through such an activity, we can find out whether the soil or sand from given place contains particles that have iron. So here with this we can come to a conclusion that this sand contains iron, or it is a pure sand or soil. If at all we are putting a magnet and we see that there are some particles attracted towards this magnet, then you can say that this soil or this sand contains iron particles. If not, if it is a clear one, which you can see in the figure C, then you can say there is no iron pieces in the sand or soil. So with this activity we can come to this conclusion. So through such an activity we can find out whether the soil or a sand from the given place contains particles that have iron. Try this activity near your home, school, or at the place you visit at your holidays. Does the magnet with iron fillings sticking to it look like any of these shown in the figure 13.6? So the same way, if you have observed in this kind, if it is too many particles, then you can say there are too many iron pieces in the sand. If they are very less, there are very few, you can say few of the iron pieces are present in the soil or sand. If there is nothing, you can say none. If you fill this table and send it to your Paheli and Boju, they can compare the amount of iron filling found in soil from different parts of the country. They can share the information with you. So here he is telling us that there is the figure, table 13.2, where he is asking us to rub magnetic rubbed in soil. So what I have told you, the same thing he is asking us to do. So imagine the name of the colony, like you are going to the school in your like near your home, and on the road, you can say anywhere. So let us take it as near your father's office, anything. So here in the school, how did you find iron fillings in the stick to the magnet? So many, very few, or none. So here you can give, if in the school, if you have found many, you can say many. If you have found very few, you can say very few, or none. The same goes on. So if you have filled this table, he's asking us to send it to Paheli or Boju so that they can compare it with the other like these amount of iron fillings that they have found from other parts of the country, and they will share the information with you. So let us come to the next one, that is poles of magnets. So let us now, you know what are magnetic and non-magnetic substance or materials. Now we will learn about the poles of magnets. So spread some iron fillings on a sheet of paper. Now place a bar magnet on this sheet. So now what we are asked to do is, we are asked to take a piece of paper and we are going to spread some iron fillings on that paper. After that, what we are going to do is, now place a bar magnet on this sheet. What do you observe? So what you will do, you will take a piece of paper. Now imagine this is a piece of paper. There you are keeping this iron pieces on this. Then after that, we are taking this iron bar, this magnetic bar magnet, and placing it on the paper. So what will you observe? Do you know? Do the iron fillings stick all over the magnet? Do you observe that more iron fillings get attracted to some part of the magnet than other? Remove the iron filling, sticking to the magnet, and repeat the activity. Do you observe any change in the pattern with which the iron fillings get attracted by different parts of the magnet? So here what he is telling us, to spread the iron pieces and take the bar magnet and place it on the paper. So you will see that all the iron pieces will get attracted towards this iron bar, like bar magnet. So what will happen? He's asking, both the sides they are getting equally attracted, or one side less or one side more, is the question asked to us. So again and again he's asking us to repeat this activity and see whether they are getting stuck up both the side on the equal parts, equal amount. You can do this activity using pins or iron nails in place of iron fillings, and also with magnets of different shapes. So not only a bar magnet, but you can use a horseshoe, or you can use that so many cylindrical one, or etc. Any one you can use, and not only this one, and you can do the different kind of activity, and you can see whether they are getting attracted in the same way and the same amount on the both the sides. Draw a diagram to show the way iron fillings stick to the magnet. Now this one you can draw in a paper, and you can see that filling of the stick like iron filling is getting attracted towards this magnet. Is your drawing similar to that drawing in this 13.6? So here you can see how much they have got attracted. So in 13.7 here you can see too many iron pieces got attracted, whereas in the figure 13.6 here you can see only a few pieces are getting attracted. So are these two images the same? Are they looking the same? Are they same? No. We find that the iron filling are attracted more towards the region close to two ends of the bar magnet. Poles of the magnet are said to be near these ends. So what is happening here? The iron pieces are very close. So they are very close means what happened? They are getting attracted. Too many of them are getting attracted to the ends of the bar magnet, because the poles of the magnet are said to be near these ends. So the poles are at the end of this magnet. That is why the attraction is more. Try and bring a few magnets of different shapes to the classroom. So here we are asked to bring few different types of magnets to the classroom and observe this activity. Check for the location of the poles on these magnets using iron filling. So what we are going to do, we are going to take this iron pieces and we are going to check the poles of this magnet using this iron fillings. Can you now mark the location of the poles in the kind of magnets shown in figure 13.4? So as we have seen those different types of magnets, that figure 13.4, the same way he is asking us, can you show the different kinds of magnets? On those different kinds of magnets, can we show the poles? That is asked here. So here we got to know that there are poles present in the magnet, and there are two kinds of material, that is magnetic and non-magnetic materials.